Welcome students to online classes of mathematics for class 9. In this video we are going to study the chapter number 7, which is triangles of NCERT textbook. In this video we will be covering the remaining question of exercise 7.1, and this is session number 1 for this particular chapter. Myself Deepak Gautam, TGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. Question number 4 is L and M are two parallel lines intersected by another pair of parallel lines P and Q. Okay, so we have two parallel lines L and M, and they are intersected by another pair of parallel lines, which is P and Q. Okay, we have to prove that triangle ABC is congruent to triangle CDA, which are triangle ABC is this one and CDA is this one. We have to prove that these two triangles are congruent. Okay, this one is very simple, as it is given that these, like you can say, these two sides are parallel, so their alternate interior angle C, this DAC, and angle ABC will be equal. Similarly, as these two sides are parallel, then they correspond their alternate interior angle BAC, this one, and angle ACD will be equal, and the side AC is common for both the triangles. So by angle side angle property, these two triangles will be congruent. Okay, so let's write the solution. Answer number 4. First we will write the given portion. Given is two parallel lines L and M are intersected by another pair of parallel lines P and Q. That is two parallel lines P, not P, first here, L and M are intersected by another pair of line P and Q. Okay, we have to prove that triangle ABC is congruent to triangle CDA. Okay, let's start its proof. Proof is, like I told, alright, as line L and M are parallel and AC is a transversal, right? As L is parallel to M and AC is a transversal, therefore, okay, we are having this line. First erase this as, okay, we will be talking about the two angles. Which angles will be, we are taking L, M and parallel, and then their alternate interior angle, these two angles will be equal. Okay, therefore angle ACB will be equals to angle CAD. Okay, and we have this AC equals to A. This is by alternate interior angles. This is alternate interiors angles. Okay, next we have that this AC is equals to AC, which is common for both the triangle. Okay, common for both the triangle. Okay, then we have, now we are taking the parallel lines P and Q. In that case, this angle BAC and angle ACD will be equal. Okay, so write also as P is parallel to Q and AC is a transversal, therefore the angle BAC and ACD, angle BAC will be equals to angle ACD. This is again by alternate interior angle. This AIA stands for alternate interior angle. Okay, so what we got here is, now we got an angle A, then a side S and another angle A. So this is angle, side angle. So I'll write therefore triangle ABC is congruent to triangle CDA. Okay, and this is by angle side angle congruency rule. Okay, so that's what we were asked to prove here, that triangle ABC is congruent to triangle CDA. Okay, we have proved that they are congruent by ASA congruence rule. Okay, moving ahead to the next question, we have question number 5. This is again very simple. It says line L bisect the angle A. So we have this line L which is bisecting this angle A. That means this part of angle is equal to this part of the angle. Okay, then it says BP and BQ, this BP and BQ are perpendicular from point B to the arms of angle A. Okay, so we have two perpendiculars BP and BQ from point B on the arms of angle A. We have to prove two things here, that triangle APQ, this one, and triangle AQB are congruent. Okay, this we can easily prove them congruent by, let's raise this first. Okay, so we have this angle of 90 degree each as they are perpendicular. Then we have, as this line L is bisector of angle A, that means this part of angle will be equal to this one, and this AB is common for both the triangles. So by angle side AAS property, we can prove that these two triangles are congruent. Okay, so let's start the answer. Number 5, we have, first we'll write the given portion. Given here is line L, a line L bisecting angle A, and BP and BQ are perpendiculars from B to the arms of angle A. Okay, this is what this is given in the question, like line L bisects angle A and BP and BQ are perpendicular from point B to the arms of angle A. Okay, we have to prove here two things to prove. First, we have to prove triangle APB is congruent to triangle AQB. Okay, second, we have to prove that BP is equals to BQ. Okay, once we prove that these two triangles are congruent, then by simplicity they will be equal. Okay, so let's start the proof of part 1. Okay, first you'll write as BP and BQ are perpendicular from point B to the arms of angle A, that is the angle, these two angles APB and AQB. Angle APB will be equals to angle AQB, and each will be of 90 degree. So write each of 90 degree as they are perpendicular. Okay, so the angle will be of each of 90 degree. Then we have another angle which is angle A bisected by the line L. So I'll write as line L bisects angle A, therefore because line L is bisecting angle A, therefore the angles, this angle BAP and BAQ, angle BAP will be equals to angle BAQ. Okay, they will be equal. This is also given because line L is bisecting the angle A. So we got these two angles. Then we take this side AB is common for both the triangle. So we'll write and AB is equals to AB, which is common for both the triangle. Therefore triangle which we have to prove APB will be congruent to triangle AQB. This is by we have this angle and side by AAS congruence rule. AAS congruence rule. Okay, so we have proved the first part that triangle APB is congruent to triangle AQB. Okay, now come to the second one. Second, we have to prove that these two sides BP and BQ, these sides are equal. So since we have proved that the triangles are congruent, so the corresponding parts will be equal. So I'll write since triangle APB is congruent to triangle AQB. Okay, therefore this side we have BP and PQ. BP and BQ will be equal because they are corresponding parts of congruent triangle CPCT. Okay, so that's the solution for the question number 5. Now moving ahead to the next question, we have question number 6. This is also very simple. Just listen to it. It says AC and AE are equal. So this side AC and AE. AC is this one and AE is here. They are equal. Also we have AB and AD are equal. So this side AB and AD, these are also equal. Then we are given one more thing, that is angle BAD and EAC. Angle BAD is this one and EAC is here. These two angles are also equal. We need to show that BC and DE, this side, this BC and DE are equal. That's what we have to prove. Okay, let's start the answer number 6. First we will mention the given part. Given here is AC equals to AE, AB equals to AD, and angle BAD is equals to angle EAC. We need to prove is that side BC is equals to DE. We have to prove that BC is equals to DE. Okay, let's start its proof. Proof, as I said, now you can see easily. We have one pair of side equal, these two. We have another pair of side equal, these two. So we have SS and their included angle. The included angle is also given, that BAD and EAC is equal. But when you consider, let's see the two triangles separately first. I will mark them with different color. Okay, so first triangle is this one, ABC, this one, and second triangle is this triangle AED. So we have these two triangles. Again, I hope you can see these two triangles separately. So here for the blue triangle and green triangle, one's corresponding side is equal. Similarly for blue and green triangle, the another corresponding sides are already given equal. But for the blue triangle, the complete angle is this one, and for the green triangle, the complete angle is this one. But we are given their portions are equal, so we are going to add this part of the angle to the both ones so that their complete angle will be equal. Okay, so we'll write it as in triangle. So we have two triangles which are ABC and triangle ADE. We have what we have here is the side AB is equals to AD. This is given. Then we have the angle BAD is equals to angle EAC. This is also given. So what we're gonna do here is we will add this angle DAC. Okay, we'll write on adding angle DAC on both sides in above equation, we get, okay, in this equation we'll add this DAC on the both sides, so it will be angle BAD plus angle DAC equals to angle EAC plus angle DAC. Okay, so when you add in BAC is this one and we are adding this one, so this will become complete angle BAC. So the result of these two will be complete angle BAC. And similarly, this we are given this part and we are adding this angle DAC, so it will become EAD. It will become angle EAD. Okay, so we are also given, and we given on the another side that AC is equals to AE. AC is equals to AE. So what we have got here is we got one side, then included angle, and another side. So two side and one there included angle. So these two triangles will be congruent, right? Therefore, triangle ABC is congruent to triangle ADE, and this is by side angle side congruency rule. Okay, and we are asked here what you can say about BC and DE. They will be equal, so right, hence this BC will be equals to DE. Why they are equal? Because they are corresponding parts of the congruent triangle CBCT. Since we have proved that these two triangles are equal, so their baseline, this BC and DE, will be equal. Okay, by CBCT, corresponding parts of congruent triangle. Okay, I'm moving to the seventh question, number 7. AB is a line segment, so we have this complete line segment AB. P is the midpoint. As this P is the midpoint, that means this AP and PB are equal. D and E are the point on the same side of AB, so AB में same side में, यानी कि दोनों अपर साइड में ही होंगे. ठीक है, D and E such that BAD and ABE are equal. Those angles are, yes, BAD, this angle is equals to angle ABE. ABE is here. Okay, then we have EPA angle EPA, this one is equals to angle DPP here. Okay, we have to prove two things again here. First one is that the angle triangle DAP is congruent to triangle EPB. Okay, first one. Second, AD equals to BE. So simply we'll apply one of the congruency rule. So by that we will prove that these two triangles are congruent. Then by CPCT the second condition will be proved. Okay, so in this question you can clearly see, you can see that we have one angle, one side, but for the triangle A, this triangle APB, its complete angle is this one, but we are given only this part. Similarly for this triangle EBP, its complete angle is this one, but we are given only in this portion. Okay, so what we're gonna do here is we will add the angle. We'll add this portion of the angle to the both, first this one and this one, so we'll get this third angle will also be equal, so we'll get angle side angle. Similarly angle side and angle. By ASA these two triangle will be proved congruent. Okay, so let's start its answer. Number 7, we'll first write the given. given here is a line segment AB and P is a midpoint of AB. Okay, then we have 2 points D and E are such that the angle BAD is equals to angle ABE and angle EPA is equals to angle DPB. Okay, so we have these two angles equal given. This is given. Okay, so now we'll write to prove. We have to prove two things. First one is that triangle DAP is congruent to triangle EBP and AD is equals to BE. Okay, now let's start. Now let's start this proof. Okay, as I said, we are given two sides and corresponding sides equal, one corresponding angle equals, but we have to only find that this third angle is also equal. So first we'll write in triangle DAP and triangle EBP, we have what we have here is the angle DAP is equals to angle DAP we have angle BAD equals to angle ABE. Okay, we can write this angle BAD as BAD is here from starting from here BAD. We can reduce this point till P, so we can write PAD. Okay, we can write this as or angle PAD. Similarly, this ABE can be reduced to PBE. Okay, this can be written as angle PBE. Okay, so that what we did here is, instead of considering this straight complete line, for this angle we are taking it from point PBE, and for second angle we are taking PAD. Okay, so this is given. Okay, we have changed it as angle PAD is equals to PBE. Then we are given as P is midpoint of AB, therefore this AP will be equals to PB. Okay, as P is the midpoint of B, so these two portions will be equals, AP will be equals to PB. Now we'll write, and it's also given that EP is equals to DPB. We have angle EPA equals to angle DPB. Okay, EP is equal to DPB. Now what we're gonna do is we will add this angle to the board, which is angle DPE. So write on adding angle DPE on both sides in above equation. We get in above equation we get what we get is we'll add write this EPA angle EPA and we will add angle DPE to this. Similarly on the other side we have angle DPB and we will add angle DPE. Okay, this will give us EPA plus DPE, this EPA, this angle plus EPB will give us angle APD. This will give us angle So when you add these two you will get here angle APD. On this side we'll have angle BPE. Okay, so now you can see that what we have got here is we got an angle A, we got a side S, and we got another angle A. So by angle side angle congruence rule these two triangles will be congruent. Okay, so right therefore triangle DAP and EPB, triangle DAP will be congruent triangle EPB. Okay, EBP, this is by angle side angle congruence rule. Okay, so we have proved the first part that these two triangles are congruent. So second part will be as triangle DAP is congruent to triangle EPB, therefore their corresponding parts this side AD will be equals to BE and that 2 by CPCT. Okay, by CPCT, since these two triangles are congruent, so their corresponding side AD and BE will be equal. These two sides AD and BE, these two sides will be equal. Okay, so that's the answer of question number 7. I'm moving ahead to the last question of the exercise, which is question number 8. It says in right triangle ABC, the C right angle at C, M is the midpoint of the hypotenuse AB. So we have right triangle this ABC, right angle at C. We have M which is the midpoint of AB, that means this AM and BM are equal. Okay, now C is produced to point M. This C is produced from point M till point D. Okay, such that DM and CM are equal. So these two are also equal. Okay, M is the midpoint of AB, so these two are equal, and it is given that we have extended this CM till point D such that this CM and DM will be equal. Okay, D is joined to point B, and we have to prove 4 things here. First, that angle AMC sorry, triangle AMC is equals to BMD. AMC is this one. AMC is equals to BMD. Okay, we can easily prove that because since M is the midpoint, so these two sides are equal. We have by construction we have extended this CM till point D such that these two sides are also equal, and the angle here will be equal because they are vertically opposite angle. Okay, so therefore by side angle side these two triangle will be congruent. Okay, let's write it answer number 8. First we'll write the given part. Given here is, in right triangle ABC, in right triangle ABC, M is the midpoint of AB. Okay, and CM is produced till point D such that DM is equals to CM. DM is equals to CM. Okay, we have to prove 4 things here. First one is triangle AMC is congruent to triangle PMD. Second is triangle BDC is a right angle. Angle BDC is a right angle. Third one is triangle DBC is congruent to triangle ACB. And the last one is CM is half of AB. Okay, so let's start the proof of each one by one. Proof of part 1. Okay, as it is given in the question that M is the midpoint of, we first write in triangle AMC and triangle PMD, we have what we have is we have side as M is midpoint of AB. As M is the midpoint of AB, therefore AM will be equals to BM. Okay, this is given. Okay, next we have that as AB intersect DC, as AB intersects CD at point M, therefore angle AMC will be equals to angle BMD, and they will be vertically opposite angle. Okay, so we got here one side, which is this one side, and we got angle. Now we'll write the third side, and it's given that in the question DS is equals to CM and CM is equals to DM. This is given, which is the side. So by side angle side congruence rule, these two triangles will be congruent. Therefore triangle AMC will be congruent to triangle BDC. MD, and that is by side congruence rule. Okay, side angle side congruence rule. That's the proof of the part 1 of this question. Now come to the second part. We have to prove that angle DBC is a right angle. We have to prove that angle DBC, which is this one, is a right angle. Okay, as you can see, it's given that this angle here is 90 degree. Okay, now the second part is now we have to prove that this angle DBC is a right angle. So that angle is here. So we'll prove this by, let's write as triangle AMC is congruent to triangle BMD. Okay, so this implies that this BD is equals to CA. Why? This BD will be equals to CA by the CPCT. Okay, corresponding parts of congruent triangle. Also, the angle BDM will be equals to angle ACM. The angle BDM will be equals to ACM. These two angles will be equal because again they are corresponding parts of congruent triangle CPCT. In the chapter 6 we have studied that if two alternate interior angles are equal, that means the line will be parallel. Okay, we have studied theorem in chapter 6 which says if two alternate interior angles are equal, then the line has to be parallel. So this will give, so right, therefore the line BD has to be parallel to CA. Okay, this is theorem 6.3 of chapter 6, which says if a transversal intersect two parallel lines and one pair of alternate interior angles is equal, then line has to be parallel. Okay, you can refer it from the chapter 6. Okay, this is theorem 6.3. If the alternate interior angles are equal, then the line has to be parallel. So if the lines are parallel, therefore if the lines are parallel, in that case these two angles will be the angle on the same side of the transversal. So we have now this parallel line. Now the transversal will be BC, and these two angles are the angle on the same side of the transversal. Okay, or you can say therefore the sum of angle CBD plus angle BCA will be equals to 180 degree. Okay, since they are consecutive, the sum of the consecutive angle on the same side of transversal is 180 degree, and we have BCA as 90 degree, so it will be CBD plus 90 degree equals to 180 degrees. So angle CBD will be equals to 180 degree minus 90 degree, and angle CBD will be equals to 90 degree. Okay, this is by the theorem 6. It was 6.4, which says the sum of the angle on the same side of transversal is supplementary. Okay, you can again refer it from the chapter 6. So we have proved that angle CBD or DBC is right angle. CBD and DBC are, you can write this angle also as angle DBC equals to 90 degree. Okay, now moving to the next part, we have third part, that is triangle DBC and ACB. Triangle DBC is this one and ACB is this one. We have to prove that these two triangles are also congruent. Since we already have this side equal these two angle 90 degree and this BC is common, so by side angle side these two triangles will be congruent. Okay, so I'll write in triangle we have triangles DBC and ACB, DBC and triangle ACB. We have side DB is equals to this side DB is equals to side AC. Okay, proved above. This is, and angle DBC is equals to angle BCA, each of 90 degree. This is proved above. Each of 90 degree, and we have the baseline of both triangle BC is equals to BC. This is DBC, right? Not BBC. And the side BC is equals to BC, which is common for both the triangle. Therefore, triangle DBC is congruent to triangle ACB by the property side angle side. Okay, so write by SAS congruence rule. Okay, now the last part is, fourth one is, we have to prove that side CM is half of AB. So since we have proved that these two triangles are congruent, so write since triangle DBC is congruent to triangle ACA is congruent to triangle ACB, therefore side AB will be equals to this side AB will be equals to CD. So we'll have CD will be equals to AB. This is by CP CD, corresponding parts of congruent triangle. Okay, so it's saying CM is, we can write this DM as half of CM. Okay, if we multiply 1 by 2 on both sides, so it will be half of CD equals to half of AB, and half of CD is CM. You can see from the figure the half of this CD is this CM. We can write, so CM will be equals to 1 by 2 AB, and that's what we were asked to prove in the last part, that CM is equals to half of AB. So with this we have completed all the question of exercise 7.1. With this we have concluded the exercise, and I hope you understood all the question. So what you have to do is practice all this question multiple times so that you can understand them better. Okay, so that's all for now.